Okay, this is bit of a flipped learning video where the aim is that I do some of this teaching and you watch it as a homework, and that enables us to, for when we come into class, we have more time, well, less time of me talking and more time of you practicing questions under the supervision of a teacher and other students. So hopefully we like this type of method and we can do it a bit more in the future. So what I'm going to go through today is the back half of chapter 5.2 in the core textbook, which talks about intersection of lines, and then chapter 5.3 in the textbook, which talks about parallel and perpendicular lines. These span over exercises 5D, 5E and 5F. Okay, so into that first example here, the intersection of lines. So from our work with simultaneous equations, we can actually use that in this case. So determine the value of p, that's where they intersect. So we can use simultaneous equations here. To find points of intersection. So in this case, well, if y equals to 3x and then x plus 2y equals to 4, well, we can say that this is x plus 2 lots of 3x equals to 4. So this would be 6x, and then with this extra 1, so 7x equals to 4. So x equals to 4 over 7. It's a coordinate, so we actually want to find the corresponding y value. So I'm going to plug it into this equation here. So y equals to 3 lots of 4 over 7. This is going to be 12 over 7. So my coordinate of p will be 4 over 7, comma 12 over 7. And that looks somewhat accurate depending on this diagram. Less across and more up in both in the positive quadrants. Where it intersects the x-axis, well, this is where y equals to 0 on the x-axis. It's down here. So we need to substitute y equals to 0 into the equation they've given us, which is this line sloping downwards. So x plus 2 lots of 0 equals to 4. So x equals to 4. You need to write this as a full coordinate because we're talking about the coordinate of q. So q is going to be 4, 0. So pause the video, have a go at this question, and then replay it as soon as you've had a go, and I'll go through it and you can check your answer along mine. Okay, hopefully you've given this a good go and you're confident with your answer. I'm just going to work through it. If you kind of want to skip forward maybe a minute or so to get my solution, and if you need to go back to, if you got it wrong, then to watch the full solution, feel free to do that. So the straight line passes through these 2 points. So -1, 3, and 11, 12. We want to find the equation. So what we can do here is first find the gradient. And we know the gradient is the change in y over the change in x. So the change in my y values here is 9. 12 take away 3. And the change in my x values is 12. Make sure you didn't say 10 for that, because we're going to -1. So the gradient here is 9 over 12. Well, we can simplify that to be 3/4. From class, you'll know that we have this new formula of y minus y1 equals to the gradient times by x minus x1, where you can pick any coordinate for your y1 and x1. I'm going to pick this first coordinate, I think. I'm going to pick this 1, 3. So this is going to be x1 and this is going to be y1. So y minus 3 equals to the gradient, which is 3/4. And I'm doing minus 1, so this would turn into a positive 1. That's why I chose it, because I thought the minus I know will disappear. So expanding my bracket turns it into this, and then I'm going to, first of all, I would have already looked at the question and thought, well, I don't want it in the form y equals something, I want it all with integers. So actually, times in by 4 at this step would make quite a lot of sense. So 4y minus 12 equals to 3x plus 3. And now I'm going to move everything over from the left side to the right side. So 0 equals to 3x minus 4y, and then I'm adding on the 12, so plus 15. So that will be my final equation. If you moved all of this stuff over to the left, that would also be a valid form and you wouldn't get it wrong. So you could have a minus 3x plus 4y minus 15. That would be correct also, so you could give that mark. You can mark that correct if you had that. We also get another line. Find the coordinates of the point of intersection. So again, this is simultaneous equations. Let's try and find a kind of a smart way to do this. It doesn't seem so. So I would rearrange one of these to get you a solo x or y. I'm going to rearrange this one to give me a solo x. So x equals to 4 over 3y minus 5. What I've done is I've moved these two, the y's and the numbers, over, and then divided by 3 all in one step. Then I'm going to substitute it into this. So 3y plus 4 lots of 4 over 3y minus 5 minus 30 equals to 0. So 3y plus, this would be 16 over 3y minus 20 minus 30, so I'm going to change that to minus 50 all in one go. I'm going to times this all by 3 just to get rid of my fraction, and at the same time I'm going to move these together. So timesing this by 3 would be 16 and 9, so that's 25y. And this would be minus 150. I'm going to move that to the other side of my equation in one go. So 150 divided by 25, that would be 6. So y equals to 6. I just need to find a corresponding x value. So going over to here where I've got my nice simplified form, well, it's 4 over 3y. 4 over 3 times by 6 would be 8, and then take away 5 would be 3. So my coordinate for this would be 3, 6. Okay. That links up to exercise 5D. If you're wanting an extra question or two practice before you come into the lesson, then that's where you can look at. But we'll be looking at these questions, the harder questions in this exercise in class. Now we're going to look at parallel and perpendicular lines. So we can see that I've got some lines that you'll hopefully would recognise are perpendicular. So the gradient of this purple line that I'm hovering my mouse over, hopefully you can see that. Or this line I'll draw on top just in case you can't see that. Well, to find the gradient, we want to see, well, we're going 2 across to then go 1 up. So this would have a gradient of 1 over 2. And then if we check this one, well, we go 1 to the left and then we go 2 up. So it's looking like a gradient of 2, but because it's a negative slope, it would be negative 2. And then in this case, we're going 1, 2, 3 to the left and 1 up, so this would be minus a third, this gradient. And then the red one going upwards would have a gradient of 3. See if you can notice anything between these numbers, and read this little note down here. You can pause the video to have a bit more time on that. With perpendicular lines, we have a little formula here where if one gradient is m1, the other gradient is minus 1 over the gradient. So looking at this example, if the gradient's 2, the gradient of its perpendicular line is minus 1 over 2. If the gradient is minus 3, then the gradient of the perpendicular line would be positive 1 over 3. One must be negative, one must be positive. A good way to check that if something is perpendicular is if you multiply the two gradients together, it should give you minus 1. You can see if you multiply these two together, it will give you minus 1. So if we have a quarter now, well, we've got a quarter, see if you can figure out what the rest of these are. So I'll let you pause it and see if you can figure out the rest of these. Okay, I'm going to reveal these. So this one would be minus 4. If we times these two together, it's going to get us minus 1. This is quite similar to the first, so we'd want negative 1 over 5. It gets a little bit harder here, but if you do 1 over a fraction, so 1 over 2 over 7, what that does is that flips the fraction around because of our keep change flip with our divisions of fractions. And then this final one is minus 5 over 7. It's a useful skill to be able to do this quick in your head, so kind of re-watch through that if needs be. We've just got a few final examples and then one question for you to have a go at, and then we're done. So the line goes through this point and is perpendicular to another line of this. So the gradient of this line is 3. So the gradient of the perpendicular line, well, that's going to be minus a third. It goes through the same point, so what we have at the moment is we have a gradient and a point. So we can find the equation of this line. Y minus y1 equals to m brackets x minus x1. So y minus 10 equals to minus a third x minus 9. Maybe straight away I want to times by 3 here. So 3y minus 30 equals to, remember we still have a minus 1 here, so this would be minus x, and instead of this being a minus 9, this would be positive 9. You could really leave it like this because that is an equation of the line. They've not asked us to put it in any format. They've not asked us to put it in y equals mx plus c or ax plus by plus c equals to 0. So really I'm probably doing a bit too much work here, but what I am going to finish this off and write it in the ax plus by plus c equals to 0 format. So I'm going to add x to both sides, and then I'm going to take away this 9 as well, just to get it in the format like so. So that would be the equation of the perpendicular line. Question 2. Line L goes through these 2 points. The second line is perpendicular and passes through the point B. Where does it cross the x-axis? So first of all we want to find the equation of line B, of L2, sorry, and then we want to see, well, where y equals to 0 to find the cross of the x-axis. So let's go ahead and complete that plan. So first we want to find the gradient between A and B, and that's going to tell us the gradient of L1. Because we have 2 points for that, we can do that. So the gradient would be the change in y over the change in x. So the change in y from minus 1 to 3 would be, so minus 1 take away 3 would be minus 4. And then the change from 3 to 1 would be 2. So the gradient of this is minus 2. And just to convince yourself that this is a negative gradient, just quickly plot the points. So 3 minus 1, and then 1. Oh, sorry, I've done that really bad, haven't I? 3 minus 1, and then 1, 3. So we can tell straight away that should be a negative gradient. My minus 2 looks like it's good. So then the gradient of L2, which is perpendicular, should be a half, because we're doing minus 1 over this. The minuses would cancel out. So, finding the equation of L2, we're going to use y minus y1 equals to m brackets x minus x1. and we're using the coordinate b because that's where it crosses through. So y plus 1, that would be minus lots of minus 1, equals to a half of x minus 3. So timesing by 2, in this case, I'm going to get 2y plus 2 equals to x minus 3. Just going on to this line here, I'm going to make this into the same form as I've done before. So x minus 2y, so that's taking 2y to the other side, taking 2 to the other side, equals to 0. So this is my equation of L2. I've done this step. And now I want to find where y equals to 0. So that would be x minus 5 equals to 0. So x equals to 5. So where does L2 cross the x-axis? My answer would be 5, 0. And then just this final question. Are these lines parallel, perpendicular, or neither? Well, we know the gradient of this line would be a half. This one we might need to do a little bit of working for first, so I'm going to do that over on this side. We want it to say y equals to be able to easily tell a gradient. So if I add y to both sides, that's going to say y equals to 2x plus 4. So the gradient of this is 2. Well, we know if perpendicular, they're clearly not parallel, are they? I feel like I didn't need to say that, but they're clearly not parallel. If perpendicular, then m1 times by m2 would equal minus 1. Well, let's do that. Let's do a half times by 2. That equals to positive 1. So therefore, they are not perpendicular. So in fact, the answer to this is neither. And if you need any further convincing, we can plot both of these graphs, either on a internet plotting tool or just through your knowledge of plotting graphs, and you would clearly see that they are neither. Okay, final question. So your turn to pause the video again and have a go at this, and then when you replay it, I'll go through the 2 questions. Okay, I don't know why I drew that line. So let's have a go through question 1. A line goes through the point 47 and is perpendicular to this line. So here we've got the gradient is 2. So the gradient of the perpendicular line, which I'll annotate with MP, well, that would be minus a half. So with my equation of a line formula, y minus y1 equals to m brackets x minus x1, we're going to have y minus 7 from here equals to minus a half brackets x minus 4. And we want to put it in the form that they've asked, so we need to do quite a bit of rearranging here. I'm going to times everything by 2. So 2y minus 14 equals to minus, then brackets here. You could times everything by minus 2 and make this side negative. I think I prefer to do it this way. So undoing the negative in this bracket, we need to times everything by minus 1, so that would be minus x, and that would be positive 4. Now let's add x to both sides, and also at the same time let's take away 4 from both sides. So x plus 2y minus 18 equals to 0. So that's going to be our answer. That's all we were asked to do. Determining the point of A, well, we know as we've got a right angle here, that's the definition of perpendicular lines, they form a right angle, so this line is perpendicular. Right now we know the gradient of this is minus a half, so the gradient of our perpendicular line should be positive 2. And as it passes through the origin, we know that this equation of the line is going to be y equals to 2x because of the gradient plus 0 because the y-intercept would be 0. Therefore we need to determine the value of a. So again we're going to use simultaneous equations to find where these two lines, this and this, intercept. So if y equals to 2x, and then y equals to minus a half x plus 4, we can say 2x equals to minus a half x plus 4, and we need to go ahead and solve this. So let's times by 2. So 4x equals to minus x plus 8, add the x on, 5x equals to 8, so then x equals to 8 over 5, and leave that as a fraction. So we've got part of our answer. We then need to think, well, y equals to 2x. So if y equals to 2x and x equals to 8 over 5, y equals to 2 lots of 8 over 5. So y equals to 16 over 5. So our coordinate of A would be 8 over 5, comma, 16 over 5. And then this links well to exercise 5e and 5f. So if any of that was from the video was a little bit shaky, you might want to just try out some of the questions from question 1 of each of them exercises. We're going to look at the harder ones when we get into class if we're confident with what I've spoken about here. I think 5a goes on about parallel lines, and 5f goes on about perpendicular lines, so you can pick the ones from there that you want to look at. Okay, hopefully this was okay and I didn't make it too long and boring. Obviously let me know if you want me to clarify anything from this video, but that's it from me. Thank you very much.